Let's go to the next one. The next one says, what is the sum of the oxidation number in a neutral compound? Already the answer is there. Neutral, it has no charge. So the answer is 0. When they say neutral compound, that means it has no charge. So the answer is 0. So the correct answer is A, 0. The next one says, which of the following reactions would be expected to have the high entropy change? Entropy change. Entropy is the randomness of a system. I told you of entropy. Entropy is the heat content of a system. Now, when heat is absorbed, what happens to the system is entropy. The particles exhibit high kinetic energy. For example, if I keep an ice block, and the ice block absorbs heat from the atmosphere, the molecules will have kinetic energy. Therefore, in melting, the heat gained is used to separate the molecules. In melting, the heat gained is used to separate the molecules. So anywhere heat is added, the particles or the molecules exhibit kinetic energy. So they say, which of these has the highest entropy change? Entropy, like I said, is the randomness of particles, the randomness of the system, how the particles move. How the particles move in that system is called entropy. Simple, the randomness of a system. Now let's see the randomness of the system. Solid to liquid. Highest entropy. All of them has entropy. All has entropy. All right? All has entropy. They all have entropy. All of them have entropy. But they say which one is the highest movement? In what phase of matter will the particles move faster when they are experiencing a change to another phase? That's what it means. In what change of matter will experience highest movement? Now, when it says solid to liquid, solid melts slowly. They don't melt one time. They don't melt vigorously. They don't just melt immediately. They melt slowly. So in that case, the entropy is not high. The randomness of the particles is not high. Liquid to gas. Liquid to gas. If you check, if you're boiling water, you see that the particles move faster. That means to say the liquid expands by boiling. When heat is added, all three states of matter expand. The solid expands by melting, liquid expands by boiling, and gas expands by evaporation. Gas to liquid is a gas already, it's going to liquid. It's by condensation. It's a constant. When the vapor touches the cooler surface, it changes to liquid, so it's a constant. Gas to solid, the sublimation, is a slow process. Liquid to gas, when you're boiling water, you see that the particles are moving randomly. And as the particles are moving randomly, evaporation is increasing. So as they're moving randomly, evaporation is what? Increasing. Now, when the bumping occurs, when I mean bumping is the indication of boiling. Bumping is the indication of boiling. When you see those bubbles, especially those bubbles on the surface of the water, for example, those things is called bumping. That's when we know that the water is boiling. Why the sound of boiling or the sound of overheating is called fizzing. Before this bump will occur, there will be a sound of water. When you boil water, you see that the water will first of all bring a sound before it can show that indication of boiling. It's called fizzing. Now, when this is happening, the particles are moving faster from the bottom of the substance to the surface of the water. You see them moving. So as the heat is increasing, their movement is increasing. Their kinetic energy is increasing. So in that space, you see that the randomness of the system is increasing. So the liquid changing to gas has the highest randomness, has the highest entropy of a change. So the correct answer is B, when a liquid changes to gas. Let's go to the next one. The next one says, when an acidic solution is diluted, what happens to its pH? pH simple means potential of hydrogen. Potential, the strength of hydrogen. Now, when you dilute hydrogen, the strength of hydrogen decreases. It does not remain the same. It does not. It's like I bring juice. Now orange juice is acidic. Okay? Orange has an acid called ascorbic acid. All right? That's vitamin C. That's the name of vitamin C in acid way. It's called ascorbic acid. Now, when I pour water, I pour water into the orange. You see that the orange will not be sweet again. That means to say the strength of the orange has what? Decreased. So the pH, the potential of hydrogen, the strength of the hydrogen, pH means potential of hydrogen. The strength of the hydrogen will definitely what? Decrease. Because every diluted substance decreases the efficiency of that substance. So the correct answer is B. Correct answer is A. It decreases. Let's go to the next one. Next one says, what is the trend of ionization energy across a period in the periodic table? I told you to take note of your periodic table and the atomic numbers. When I was talking about the most repeated topics, I said take note of the periodic table. Take note of the periodic table. Now, first of all, what is ionization energy? That is the problem. Ionization energy is the energy required to remove an electron from an isolated atom. Ionization energy is the energy required to remove an electron from an isolated atom. Now, what does the bonding? What forms a compound? What bonds is the electron that bonds with another electron? Now, ionization energy talks about the valence electron. A valence electron is the electron found at the outermost shell of the atom that can be shared to another atom. A valence electron is the electron found at the outermost shell of the atom that can be shared to another atom. Now, for the electron to be shared to another atom, it must have to be removed. Now, that energy used in removing the electron from that atom to another atom is called ionization energy. Now, bringing it to the periodic table. The periodic table is the arrangement of elements into groups and periods according to the atomic number. Therefore, the elements are arranged in the periodic table according to the atomic number. Atomic number is simply the number of protons in an element. Now the number of protons quantifies the number of electrons. Quantifies the number of electrons. That is why the atom is electrically neutral, because it has equal number of protons and electrons. The atom is electrically neutral because it has equal number of protons and electrons. So therefore, as the atomic number is increasing, the amount of energy used to remove an electron from that element will be increasing. Because the number of protons quantifies the number of electrons. The number of protons tells us the number of electrons. So if an atom has an atomic number of 22, the number of electrons must be 22. So therefore, the energy used in removing 22 electrons will be more than the energy used to remove 10 electrons with an atomic number of 10. So as the ionization energy, as the atomic number is increasing, because as you're moving the periodic table, the atomic number is increasing. Hydrogen is 1, helium is 2, lithium is 3, beryllium is 4, boron is 5, so they are increasing. That is how their valence electrons are doing what? Increasing. That's how the electrons are increasing. So the energy used to remove them will be what? Increasing. So the correct answer is it increases from left to right. Because as they're going from left to right, the atomic number is increasing in the periodic table. So the ionization energy will be doing what? Increasing. So therefore, as the atomic number is increasing in the periodic table, so the ionization energy is increasing in the periodic table. So the correct answer is A, increasing from left to right. Now let's go to the next question, which is question 25. They say balance the following redox reaction. Balance the following redox reaction. I told you when I was talking about the most repeated topics in chemistry, I told you a balancing equation. You must know how to balance an equation. All right? A balanced equation is an equation where the coefficients or the where the coefficient or the number of atoms and molecules are equal on both sides of the equation. A balanced equation is the equation where the number of atoms and molecules are equal on both sides of the equation. That's the balanced equation. The left-hand side, when I say both sides of the equation, every equation has two sides. If you check on the screen, you will see, you will see that there's an arrow. That arrow represents the direction of the reaction. All right? That arrow represents a demarcation between both compounds. Now, the left-hand side represents the reactants, and the right-hand side represents the products. Now, they give you a reaction that is not balanced. Now, the law that binds a balanced equation is the law of conservation of mass by Antonio Lavoisier. That states that matter is neither created nor destroyed, but can be changed from one form to another. Matter is neither created nor destroyed, but can be changed from one form to another. Is this definition that gave Antonio Lavoisier the father of chemistry? So the law that quantifies a balanced equation is called law of conservation of mass by Antonio Lavoisier. So balancing of equation is using mathematical entities in making the both sides of the equation in equilibrium, making them equal. Now, in this equation, you see that the equation is not equal. The measurements are not equal. All right? Now, balancing of equation has rules. Rule number one, they say write the mass or write the number of atoms of each element. The equation says Fe subscript 2 O subscript 3 plus CO gives us Fe plus CO2. And I told you that one of the rules, the rules of balancing the equation says that write out the number of atoms of each element. Write out the number of atoms of each element. Now you share the reaction into two. Every reaction, every chemical reaction has two sides, which quantifies the reactants on the left and the product on the right. So you share the thing into two, differentiating the reactant from the product. Now here, they say write. This is 2, O is C is 1, and O is 4. This is 3, plus this one here makes it 4. While here we have Fe as 1, C as 1, and O as 2. You have written that. Now the next one says balance any element. Start with any element first. Start with any element first. Then you balance hydrogen, if hydrogen is there, and leave oxygen for the last. Start with any element first and balance hydrogen and leave oxygen for the last. In essence, you're balancing any element. After you finish, you now balance hydrogen, then you balance oxygen for the last. Follow that rule. Now, the first rule one now says we want to balance iron first, for example. Since there's no oxygen, since there's no hydrogen, we'll start with any element. The first element is iron. We'll start with that. But oxygen must be kept for the last. Otherwise, you get confused. Oxygen must be kept for the last. Otherwise, you get confused. You cannot balance. So, now, what am I going to add to iron? Here, iron is 2, iron is 1. What am I going to add to iron that will make it 2? I will add 2 now to iron. Subscript 2, O subscript 3 plus CO sub CO gives me, I'm adding 2 to iron. So iron now is now 2 now. So iron is 2 here, and iron is now 2 here. Now, looking at carbon. Carbon is 1 here. And carbon is 1 here. So carbon is balanced. Carbon is 1 here and carbon is 1 here. If you check, carbon is 1 here, carbon is 1 here. So carbon is now balanced. In balancing of equation, you should balance per element. You don't balance the whole equation, or you don't balance the whole compound. You balance per element. Work with each element. And that rule quantifies every calculation in chemistry. When you're calculating, you work with individual elements, not group elements. Now, iron is balanced. Carbon is balanced now. Now we want to balance iron, oxygen for the last. Oxygen now should be for the last. Oxygen is 4 here, and oxygen is 2 here. Oxygen is 4 here, and oxygen is 2 here. What do I add to oxygen here that will make oxygen complete? 4 here. That will make oxygen 4 here. Now, I need to, if I add 2 here, oxygen will be 4 here, and oxygen will be 4 here. If I add 2 here, oxygen will be 4 here, and oxygen will be 4 here. Now, if you check the options, and you calculate your options very well, you will see that the number of molecules quantifies a balanced equation. The number of atoms quantifies a balanced equation. Quantify a balanced equation. Now, let's take, for example, we say Fe subscript 2, O subscript 3. All right? Plus CO subscript 2. You balance where is not balanced. Fe plus 2CO subscript 2. Now, oxygen is 4 here. Oxygen is 4 here. Oxygen is 4 here, and oxygen is 4 here. Okay, but carbon here now is 2, and carbon here is 1. Carbon here is 2, and carbon here is 1. How do we do about carbon again? How do we do about carbon again? Now, this, you now say Fe O subscript 2, O subscript 3 plus. Now, oxygen is now 4 here. I say 2CO gives me 2Fe plus 2CO2. Now, oxygen becomes 2 plus 2 and 2 plus 2. 2 plus 2 and 2 plus 2. So now, the correct answer for this equation becomes B. Becomes B. Correct answer for this equation becomes B. Because if you calculate, you will see, that iron is 2 times 2, 2 Fe subscript 2, O subscript 3, plus 3CO gives me 4Fe plus 3CO subscript 2. Now, if you check, in this balancing, iron here is 2 times 2, 4. Oxygen is 2 times 3, 6. All right, in this area. And carbon is 3 here, carbon is 3 here. So the correct answer is B. Let's go to the next one. The next one says, which trace gas in the atmosphere plays a significant role in the greenhouse effect? In the greenhouse effect. You know, when they say greenhouse effect simply talks about the exposition of plants. All right? when plants are being exposed, greenhouse. When they say greenhouse, they're talking about green plants. Which trace of gas in the atmosphere plays a significant role in the greenhouse effect? They're talking about greenhouses of plants. You know, plants have, they're talking about green plants, green leaves of plants. Plants have green plants. All right? So those green plants, which gas plays a significant role of green plants? Oxygen is the emission. Okay, they emit oxygen. Nitrogen, argon. Carbon dioxide is used for photosynthesis in plants. Used for photosynthesis in plants. In essence, carbon dioxide, plants use that to produce food in order for them to gain energy. When you hear greenhouse, it talks about plants, green plants. That's what it means. Green plants. So which gas is used? Which gas is used in green plants? Which gas do green plants use? That's the greenhouse effect. It's just a way to confuse you. Which gas is used in the which gas is used in the greenhouse? In the green plants, is carbon dioxide. They use it for photosynthesis. All right? So the answer is C. The next one is, what is the chemical formula of rust, which is formed on the surface of iron in the presence of oxygen and moisture? You know, rust is due to corrosion. Corrosion is the deterioration of metals. Corrosion is the deterioration of metals due to an electrochemical process and oxidation reaction. Corrosion is the deterioration of metals due to an electrochemical process and oxidation reaction. In essence, what causes corrosion on metals is oxygen. The oxygen gains and loses electrons. The oxygen gains and loses oxygen. Now, the rust there is the red oxide formed as a result of corrosion. So corrosion is called the whipping of metals. The whipping of metals. How do you know that the metal is whipping? Is that rust. The red oxide is a reddish oxide formed, brownish red. Some people will say it's brownish red or reddish brown. All right, anyone you want to call it. Some people say it's reddish brown, but it's a red oxide formed as a result of corrosion. And the oxygen is the process, oxidation process, of which rust is formed. Now, where is the rust formed? Where does the oxygen take place is on the metal. And that metal is iron. In essence, corrosion occurs in ferrous metal. Ferrous metal are metals that contain iron, while non-ferrous are metals that do not contain iron. So the answer is Fe subscript 2, O subscript 3. Why? Because the oxygen is an oxidation process. It has a high level of impression on the iron. It oppresses the iron when it comes. That is why the iron cannot resist it. Because iron cannot resist oxygen, so they are entitled to face corrosion. So the correct answer is B. The next one is, which of the state of matter in which particles are widely spaced and move freely with high kinetic energy? What is the state of matter in which particles are widely spaced and move freely with high kinetic energy? Solid have a strong cohesive force. In essence, their particles do not have high kinetic energy. Liquids are weakly loosed. Okay, liquids are weakly loosed. They are not that loosed. Gases do not have cohesive force, so they exhibit kinetic energy. Gases do not have any cohesive force, so they exhibit highest kinetic energy. If you are boiling water and you open the water, you see the vapor going out vigorously. Okay, they are going out with that direction randomly. Why? Because they possess high kinetic energy. So the answer there is gases. Like I said, the solid have a strong cohesive force. Because of that cohesive force, they have a fixed shape, a fixed mass, and a fixed volume. Cohesive force is the force of attraction between particles in a state of matter. All right? So the solid have a strong cohesive force. Their particles are tightly bonded together. The liquid have they are lightly loosed, while the gases have no cohesive force, so they are bound to move anyhow they like. They are not being held by anything, so they are bound to move anyhow they like. So the correct answer is C. The next one says, what is the common name for ethanoic acid? The common name for ethanoic acid is called acetic acid. That's another name for ethanoic acid. Acetic acid. So the correct answer is A. So the next one says, which of the following is the primary constituent of crude oil? Which of the following is the primary constituent of crude oil? Now, these answers they gave here are somehow deceitful and confusing. Ethanol is not a, ethanol is a constituent of alkanol. Ethanol is a constituent of alkanol. All right? Ethanol is from alkanol. That's what you get from carbohydrates. That's what you get from carbohydrates. Ethanol is gotten from carbohydrates. All right? Now, methane is the primary gas of hydrocarbon. That's the first gas you get from crude oil. Take note. It's not the primary constituent. It's the primary gas of crude oil or hydrocarbon, methane. Molecular formula of CH subscript 4. Okay? Molecular formula of CH subscript 4. Now, methane is the primary gas of hydrocarbon. Ethanol is gotten from alkanol. That's an alkanol family. That's an alcohol family. It's not a constituent of crude oil. It's an hydrocarbon, quite all right. It's an organic substance, quite all right, but it's not of crude oil. I told you, organic chemistry is shared into crude oil, hydrocarbon, protein, fat and oil, and carbohydrates. So the ethanol is a group of hydrocarbon, carbohydrates, alcohol, alkanol group. Methane is from alkane, quite all right. Pentane too is from alkane. But methane is the primary gas of hydrocarbon, of crude oil. Ethanol is not of crude oil. All right. Pentane is a colorless, odorless, and tasteless gas, just like water. Odorless, colorless, and tasteless gas, just like water. This is the primary constituents of crude oil. Primary constituents. In essence, there are so many. The first product of crude oil that consists of so many things inside. That's pentane. While methane is a separate process of gas. Now, the pentane consists of methane, propane is inside, and butane is inside pentane. In essence, this pentane is a family that consists of methane, butane, and methane, butane, and propane. So it's a constituent. It has things inside. While methane is the primary gas, is alone. So they say the primary constituent. That means which of these substance, or which of this compound, or which of the product has other product inside. That's what it means. It's pentane. It's pentane. So the correct answer is C. Okay? The next question is, what is the molar mass of water? 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 Molar mass is just the sum of the masses of the element. Molar mass is just the sum of the masses of the element. It's very simple. When they give you a compound, calculate the molar mass, sum them up, bring out the molar mass and sum them up, that's the molar mass. And it's been calculated in grams per mole. That's the SI unit. It's calculated in grams per mole. Molar mass is the sum of the masses of the constituent elements. The sum of the masses of the constituent elements. That's molar mass. All right? So the molar mass of water is H subscript 2O. H has a molar mass of 1. Oxygen has a molar mass of what? 16. Now, if you check in hydrogen, hydrogen is 2. So the molar mass times the subscripts gives you the molar mass of that substance. The mass of hydrogen is 1. But in the water, hydrogen has 2 atoms. So it will be 1 times 2. Oxygen is 1. Oxygen does not have anything. So in essence, molar mass of hydrogen is 2. So 1 times the 2 gives us 2. Then oxygen is 16. So therefore, molar mass, I said the sum is equals to 2 plus 16, which is 18 grams per mole. So the correct answer is 18 grams per mole. A, that's the correct answer, A. The next one is, which noble gas is radioactive and is produced as a decay product of uranium and thorium? Which noble gas is reactive and is produced as a decay product of uranium and thorium? The correct answer is radon. Radon. Radon is a product, the definition is there already. Okay? Radon is produced from a decay of uranium and thorium. The answer is there already. Radon is produced from a decay of uranium and thorium. So if they ask you which element is produced from uranium and thorium, it's called radon. So the correct answer is A there. Which of the following methods can be used to remove temporary hardness from water? Temporary hardness from water. They did not say permanent though. First, for example, hard water and soft water. Hard water is water that has impurities. Okay, that is constituted of impurities. Hard water is the water that constitutes of impurities, while soft water is the water that is free from impurities. In essence, soft water is a distilled water. All right, soft water is the water that is free from impurities. It has no impurity. While hard water is the one that has impurities. That means to say, for every hard water, the boiling process is high. And the freezing process is still high. It has a high freezing point and a high boiling point. Hard water has high boiling point and high freezing point. All right? The processes are high. Why for soft water, it does not have a high boiling point. So it has a normal boiling point and a normal freezing point. Now, first of all, they say which of the following methods can be used to remove temporal hardness from water? Temporal hardness from water. Now, they did not say permanent removal of the hardness. When they say hardness, it means permanent removal of impurities. That's what it means. So which one can remove impurities temporarily? Temporarily, not permanently. All right? So the first one says, the D there says distillation. Distillation is pure purification of water. Like this distilled water you drink, this bottled water is being distilled. All right? You separate impurities from the liquid. You remove everything, permanent solution. All the answers look alike. Permanent solution. So distillation removes permanent, gives you permanent solution to the hardness of water. It removes all the impurities from water. But the question there says temporarily. Temporarily. Temporary. It does not say permanently. Now the next one is chlorination. Chlorination is using chlorine to remove impurities from water. You know, they use chlorine in removing impurities from water. Now, chlorine is used to purify water because it is an oxidizing agent. I repeat, chlorine is used to purify water because it is an oxidizing agent. In essence, it's used to remove impurities from water because of this reason, because it's an oxidizing agent. So when I say remove, now chlorine removes it permanently. It removes every single impurity from the water. All right? Filtration is to separate liquids from solids. And these particles are colloidal particles. They are suspended particles. All right? They are not visible solid particles. They are impurities. So filtration cannot remove it. While boiling is a process where a liquid is converted to gas at atmospheric pressure. A liquid is converted to gas at atmospheric pressure. It is a process. That means it's continuous. So as it's continuing, the impurities are reducing. Why? Because of the heat that is added upon the impurities. Not all will live, because there are some bacteria that do not die under heat. You need an extra heat to remove it. That's why distillation comes to play. So the boiling do not remove all the impurities. It removes some impurities, not all. Because like I said, some bacteria do not die under heat. They don't. They don't die under heat. So boiling is the best answer to this option, because they say temporarily, and boiling do not remove all. It removes some of it. So the correct answer is A, temporarily. When you check, when you look at a question, make sure you look at the way they set the question. Read the meaning of the question first, meaning of the question, before you can be able to answer the question. Don't just rush. Because like I said, D removes impurities. It removes hardness of water. C removes hardness from water. So if you don't know, you can take D or you can take C. But the correct answer is A, boiling. So the next one says, which group does calcium belong to in the periodic table? Now, first of all, calcium has which atomic number? Because if you don't know the atomic number, you can never know the group. You can't know the group of the periodic table. That's why I said you should know your periodic table and know your atomic numbers. The periodic table is the arrangement of elements into groups and periods, like I said, and the elements are arranged according to the atomic number. And every group has a name. Every group has a name. All right? Now, the group D element, now calcium has an atomic number of 20. Now, if you look at your periodic table, calcium is in group 2 of the periodic table. 20, group 2 of the periodic table. Now, the group D elements are called noble, noble gases are the group 8 elements or the group 0 elements. In the group, the horizontal roll is the group, while the vertical roll is the period. So the horizontal roll, the group 7 of the group 8 of the horizontal roll is called noble gases, while the group 7 elements are called halogens. The group 2 elements is B is the answer, which are called the alkaline earth metals. The group 2 elements are called alkaline earth metals, and calcium is being placed in the group 2 element. That means calcium is an alkaline earth metal. So the correct answer is B. The next one, they say, what happens to the value of equilibrium constant for a reaction if the reaction is reversed? When they say reverse, they say if it's changed. That's what it means in chemical reaction. If it's changed. In essence, there is a reciprocal. All right? There is a reciprocal. Okay, let's check the reciprocal of this reaction. Let's check the reciprocal so that you understand what I mean before we pick the answer. Reversed. A plus B, okay, AB plus BC. AB plus CD will give us CD plus AB. All right? AB plus CD will give us CD plus AB. Or you can say A plus B equals to C plus D. That means C plus D equals to A plus B. Reverse. When you're reversing it, next you're taking this back and taking this back. So there's an exchange of the reaction. There's an exchange. In essence, in this context, the product now becomes the reactant, and the reactant now becomes the product. It is called a reverse reaction. All right? That's the reverse reaction. Reverse reaction is a reaction whereby the product becomes a reciprocal of the reactant. That's the reverse reaction. Where the product becomes a reciprocal of the reactant. That is a reverse reaction. The product becomes a reciprocal of the reactant. That is a reverse reaction. So in this context, it remains the same. It cannot remain the same. Since it has changed, it can't remain the same. It becomes 0, no. It becomes negative, no. it becomes the reciprocal of the original value. For example, let me use mathematics. If I say 4 plus 5 is equals to 9, it does not mean that for 9 is equals to 4 plus 5. Simple. So the reverse of 9 gives you 4 plus 5. And the reverse of 4 plus 5 gives you what? 9. So this is the original value. 4 plus 5 is 9. This is the original value. And these are the reactants that formed 9, the original value. So when it's being reversed, the reversal will be 9 now, will be equals to 4 plus 5. In essence, the product, which is 9, becomes a reverse of the reactant. So 9 gives us 4 plus 5. So therefore, there is a reciprocal. So instead of me putting 4 plus 5, I will put 9. Instead of me putting 9, I will put 4 plus 5. So it is a reciprocal of the original value, which is 9. So the reciprocal of the reactant becomes the product. All right? And the reciprocal of the product becomes what? The reactant. Like I said, C plus D, A plus B equals to C plus D. Therefore, C plus D gives you A plus B. So the correct answer there is C. It becomes the reciprocal of the original value. So the next one is, a gas occupies a volume of 1.5 liters. At what pressure? At a pressure of 2 atmospheres. If the pressure is increased to 4 atmospheres while the pressure remains constant, what will be the new volume of the gas? This is Boyle's law. This is Boyle's law. If you check, now in gas laws, if you have pressure and volume, if you have pressure and volume, it's Boyle's law. If they give you pressure and volume, it's Boyle's law. If they give you volume and temperature, it's Charles' law. If they give you pressure and temperature, it's Avogadro's law. Take a note. If the temperature remains constant, it's Boyle's law. All right? Because Boyle's law states that the pressure of a given mass of gas is inversely proportional to its volume, provided the temperature remains constant. Boyle's law states the pressure of a given mass of gas is inversely proportional to its volume, provided the temperature remains constant. Mathematically, it's P1 V1 equals to P2 V2. That's the mathematical expression of Boyle's law. Now, in this context, they gave us pressure and volume. The temperature is remaining constant, so it's Boyle's law. If they give you volume and temperature, pressure remains constant, then it's Charles' law. If they give you pressure and temperature, then it's Avogadro's law. If they give you pressure, volume, and temperature, then it becomes an ideal gas equation or a general gas law. All right, so they say a gas occupies a volume of 1.5 liters. A volume of 1.5 liters at a pressure of 2 atmospheres. If the pressure is increased to 4 atmospheres while the temperature remains constant, what will be the new volume of gas? Now, our first pressure is 2 atmospheres. So P1 is 2 atmospheres. V1, that's the first volume, is 1.5 liters. 1.5 liters. All right? Then, I said this is the formula. P1 V1 equals to P2 V2. Then, our P2 is 4 atmospheres. Is 4 atmospheres. But our V2 is unknown. Our V2 is unknown. So now we are looking for the V2. That's what we're looking for. Now, they said it's P1, V1 equals to P2, V2. Now, solution. You have gotten the thing. So the P1, anywhere I see P1 is 2. V1 is 1.5, P2 is 4, and V2 is unknown. So it will be P1, which is 2, times 1.5 equal to 4 times V2. 4 times V2. This is it. P1 is 2. V1 is 1.5. Equals to P2 is 4 and V2 is unknown. That's what we're looking for. That's the new volume of gas. We're looking for the new volume of gas now since the pressure has increased. Because the Boyle's law tells us, quantifying the gas laws, it says as the pressure increases, the volume increases. That's what it said. It said as the pressure increases, the volume decreases. Sorry. As the pressure increases, the volume decreases. So if you're boiling water, okay, as the water is boiling, the volume of the water is what? Decreasing. Because the vapor is leaving, the water is leaving the water as vapor. Water is leaving the water as vapor. That vapor that comes out of the water when you're boiling that water is water. Because if you put your hand, for example, and the vapor touches your hand, it's still water. And that process is called condensation. When a gas changes to solid when touch a cooler surface. It's called condensation. Now, V2 right now will be equal to, since you're looking for V2, we are going to ask for. Where is V2? So it will be 2 times 1.5 all over 4. Will give us our new volume. 2 times 1.5 all over 4. Since 4 is with V2 and you're looking for V2, we are going to ask 4. That means we are going to divide it by what? 4. So 2 times 1.5, 2 times 1.5 is 3. Now 3 divided by 4 is 0.75. So it's equals to 3 over 4. 3 over 4, change it to decimal, is 0.75. So the answer is 0.75 liters. 0.75 liters. That is the answer. So the correct answer is A, 0.75 liters. So the correct answer now is A, 0.75 liters. Now let's do a check. Therefore, our V2 now is no longer unknown. It's now 0.75 liters. Now let's do a check. Okay? We've gotten our solution as 0.75 liters. Let's do a check. Let's do a check. Now, our P1, the equation says P1, V1 equals to P2, V2. Now, our P1, now our answer is 0.75 liters. So, our P1 is V1 equals to P2, V2. Our P1 now is 2 times 1.5. That's our P1. It's equals to 4 times 0.5. That's our P2. Our P2. So 2 times 1.5 is 3. 4 times 0.5. 4 times 0.75 is still what? 3. So it's correct. Our answer is correct. So the correct answer is A, like I said, 0.75. Let's go to the next question. Next question says, what is the chemical structure of soap and detergent molecules? Chemical structure of soap and detergent molecules. Okay. Chemical structure of soap, and now soap is a base, for example. It is soluble in water. All right? Detergents are soluble in water. So they are hydrophilic and hydrophobic. All right? Hydrophilic and hydrophobic. When you hear hydrophobic, it means it attracts water. All right? When you hear hydrophobic, it means it attracts water. And when you hear hydrophilic, it means it repels water. It does not attract water. Now, soap. Water is being used to do soap. Water is being used to do soap. All right? Water is being used to do soap. And that same water is being used to melt soap. When you hear head and tail, it talks about the making and the dissolving. That's what it means. The making and the dissolving. So what's the chemical structure of soap and detergent molecules? Soap and detergent molecules. Soap is the making and detergent is the dissolving. All right? Now, hydrophilic head means it is a water-attracting substance Why hydrophobic means it is a water-repelling substance. When they say phobia, phobic, it means you fear. All right? You fear. So soap fears water. Because when soap enters into water, it dissolves. But it is soap that is still being used. They still use water in the making of detergent and soap. And that same soap and that same water destroys soap. So the making is the head, and the dissolving is the tail. Therefore, the attracting is the head, and the repelling is the what? Tail. So when they say hydrophilic tail and hydrophobic head, hydrophilic, like I said, means making. So they do not, the tail is the dissolving. So it does not have the hydrophilic, it does not dissolve. It does not dissolve before the making. You understand what I'm saying? It does not dissolve before you make the soap. Okay? It is being used to make the soap and not to dissolve the soap first. It is only when the soap is being made with water, that's only when it can dissolve in water. So the head is the making of the soap, while the tail is the dissolving of the soap. In essence, the head, the hydrophilic, becomes the attracting of water. In the making, soap attracts water. All right? While in the usage, soap repels water. So soap is afraid of water. So the correct answer is A. Hydrophilic head and hydrophobic head. When you hear head, head means making, tail means destructing. You know that head is the starting and tail is the ending. So the end point of soap is to dissolve in water, while the starting point of soap is to be made with water. So the correct answer is A. The next one is, what is the mass percentage of carbon in methane? Molar mass of carbon is 12. Molar mass of carbon is 12. Percentage mass. Percentage mass is simply the sum of the molar masses of the element times 100. The sum of the molar masses of the element times 100. All right? It's the sum of the molar masses of the element times 100. Now, if they give you a particular element to find the molar mass, what you will do, you calculate the molar masses. You sum them first, then you use that element's molar mass and divide the sum of the elements. Then you times it by 100, you get your answer. Times it by 100, you get your answer. What do I mean? What is the molar mass of carbon in methane? Methane is CH subscript 4. Okay? They say carbon is what? 12. They gave you carbon as 12. Now, hydrogen has a molar mass of 1. Hydrogen has the molar mass of 1. But if I want to know the molar, hydrogen has the mass number of 1. But if I want to know the molar mass of methane first, I will say 12, the sum plus, hydrogen is 1 here. That's the mass. But in this compound, hydrogen is 4. So you times the mass number by the subscript of the element. You times the mass number by the subscript of the element, and it gives you the molar mass of that element. So the molar mass is now 4, which is 16. So you have gotten the molar mass of the full methane, CH subscript 4. Now they said, what is the percentage mass of carbon? Carbon is what? 12. All right? So you divide carbon by the sum of the molar mass of the compound, of the constituent elements. So it will be 12 divided by 16. Since it's percentage, you're going to divide it by what? 100. 12 divided by 16 is going to be divided by what? 100. Now, if you do this, you will see that it's going to give you 75%. It's going to give you 75%. Okay, let's just go. 4 into here is 4. 4 into here is 25. All right? So it will be 12 times 25 all over 4. It's equal to 75%. So the answer is 75%. So the correct answer is 75%. Let's go to the next one. What is eutrophication. What is eutrophication? What is eutrophication? Eutrophication, when they say the release of harmful chemicals into water bodies, that's pollution. All right? So chemicals into water, but that's pollution. That's aquatic pollution, not water pollution. The formation of oil slicks on water surface, that's forming a circular film according to Lord-Rayleigh's law. Okay, the presence of heavy metals in water is still pollution. But the excessive growth of algae due to nutrient enrichment. Eutrophication is the excessive growth of algae due to nutrient enrichment. You know, when the substance is enriched, when the soil is enriched, algae is bound to occur there because that's what they call the host and destination site. The host and the destination site. For example, if I have bacteria, I'm the host. If I give it to somebody, the person becomes a destination site. So algae becomes a host in that particular area. Now, when the algae is transferred due to the nutrient enrichment, they look for where places are enriched. Oh yeah, all right. Where their nutrients, where their food is enriched, they go to that area. Therefore, the algae becomes a destination site. But since that particular area is being filled with nutrients, they are now the host of that area. So they grow. All right? They see enough food, so they grow in that area. So as they are growing, their increase becomes eutrophication. So the correct answer is C. The increase becomes eutrophication. So the last, but not the least, is steel. Stainless steel is an alloy made up of, first of all, what is an alloy? Stainless steel is an alloy made up of, first of all, what is an alloy, first of all? An alloy is a metal or a metal composed with other substances. An alloy is a metal or a metal composed with other substances to form a superior quality and is used to prevent corrosion. An alloy is used to prevent corrosion. All right? So, how to create an alloy? The base metal is being molten first. Then the other alloy metals are being added to it. What do I mean? The metal you want to use as your main metal. All right? Then you add the other metal. I said it's a metal or a metal composed with other substances. The substances can be solid, liquid, or gas. The metal can be solid, the substances can be solid, liquid, or gas. Some people will tell you that a metal that consists of other metal. No. It's not a must that an alloy will be made of metal and metal. Like iron and iron, cranium, and carbon gives you steel. While iron and cranium gives you stainless steel. They're two different things. Iron, carbon, and cranium gives you steel. Are you seeing the difference? All right? While iron and cranium alone gives you stainless steel. So, if you don't know, it's confusing. All right? It's confusing. Iron and zinc is comprised of brass. Yes, iron and carbon, no? Iron and chromium. Like I said, iron, chromium, and carbon is steel alone. While stainless steel is iron and chromium. Like I said, a metal is an alloy is a metal that is composed of other metal or other substances to form a superior quality. It is a metal or a metal composed of other substances to form a superior quality. And it is used for the prevention of corrosion. So the correct answer is iron and chromium. Iron and chromium. Thank you very much. We have come to the end of this question and answer, of this revision questions and answers.